The demonstrator of AFarCloud is the Institute of Animal Science Prague, Czech Republic, an excellence center of biotechnology research for livestock production. 8 departments perform research in animal nutrition and feeding, genetic improvement, biotechnology and reproduction, quality of animal products, ethology and welfare, farm and technology, herd management and production economics. In addition, the Institute provides extension services for farmers and companies and public education. The Institute of Animal Science has its own experimental facilities, ministry-accredited research dairy and swine farms, where numerous experiments are performed.
The goal of demonstrator AFarCloud is to develop on-farm IoT systems to measure physiological and environmental parameters such as pH, redox potential and temperature in the cow rumen, and temperature, humidity and CO2 level in the barn, which are important indicators of animal health and well-being. The user-friendly solutions based on wireless sensor nodes, cloud technologies and artificial intelligence agents will contribute to reduced culling rate due to early detection of subacute ruminal acidosis, improved health and welfare, reduced veterinary costs, improved animal performance and increased profitability.
In the first year of the project, Institute of Microelectronic Applications contributes to the AFarCloud demonstrator by monitoring temperature and humidity on the Institute of Animal Science farm. It uses LoRa wireless sensors to monitor the environment. At the Institute of Animal Science farm in Netluky, IMA placed 2 sensors inside and outside of cowshed. It is model Rising HF wireless LoRaWAN temperature and humidity sensor. IMA has developed the AFarCloud Azure web server for data storage, processing, visualization and transfer to the third parties. Data from sensors are transmitted via paid telecommunication services of the Czech Radio Communications to AFarCloud, where they are preprocessed and stored in the SQL database. IMA has developed a cloud-based visualization application which includes management of access rights, setting of sensors and different data aggregations in tables or graphs based on the time periods. In addition to the temperature and humidity, the signal strength and battery level are monitored. From the AFarCloud, the data are transferred via the REST API to the cloud of the partner University of West Bohemians, which integrates them into SenseLog and is also available to the Charles University partner for further processing and visualization in AF service. Through these partners, IMA provides data to the AFarCloud platform.
In the scope of project, Lesprojekt company has installed the sensor nodes in stable in order to monitor air conditions inside the building. Sensors are able to measure carbon dioxide concentration, air humidity and air temperature. Stable is covered by 3 nodes, 1 in the middle of the building and 2 in the opposite entrances. Nodes are using LoRa radio connectivity provided by nationwide provider Czech Republic. In addition, all data are stored into internal non-volatile memory in case of radio network failure. One additional node measuring temperature and humidity is outside stable. The sensor node provides correlation data to data measured inside stable. To
luminol probes demonstrated in year 1 of the application scenario 7 are experimental probes that can be used for fistulated cows only and have been developed before the AFarCloud project started. The insertion of the probe through a cannula allows fast updates of the probe electronics and firmware during the development. It permits bigger physical dimensions of the probe as well, which leads to simplified mechanical and electrical design. The probes allow to measure luminol pH, redox potential and temperature in configurable interval. During the experiments was found that suitable measurement interval is 2 minutes, followed by nonlinear data filtering, smoothing and optional decimation. For pH and redox potential sensing, electrochemical sensors are used. These glass electrodes change their electrical potential depending on the sensed value. The analog signal is amplified and conditioned. The internal impedance of the electrodes is very high, therefore the amplifier must be very sensitive and perform similar input resistance to the electrodes. The preprocessed signal is sampled by an AD converter and transmitted online to a base station located in a barn close to the animals. Simultaneously, the data sample is stored in an internal flash memory so that the data can be retrieved later in case of communication failure. Implementation of a wireless data link from the rumen to the base station was a challenge. Major part of the luminol juice is water, which is almost opaque to the radio waves in the 2.4 GHz band. That is why common communication modules working in this band, like Bluetooth, Wi-Fi, Zigbee and so on, could not be used. Therefore, we have to use proprietary communication solution. The longer waves are used, the better from the point of view of the body tissues and luminol juice transparency, but the worse from the point of view of the antenna size. Finally, communication in 433 MHz frequency band was chosen. It is free, unlicensed band that can be used for ISM applications and in our case allows construction of a device with reasonably big antenna and reasonably big range. Depending on the position and orientation of the balls inside rumen, the range varies approximately from 2 to 12 meters. The electrochemical pH and redox potential sensors are subject to aging, especially in harsh environments like luminol juice wear out quite quickly. Unfortunately, all our probes have worn out sensors and their replacement is rather costly. Therefore, for the year 1 demonstration, we have updated firmware of the probes to emit simulated data acquired during previous experiments. However, the rest of the processing and communication chain remains unchanged.
Lesprojekt company has provided gateway for luminol probes running in test mode. Gateway is a combination of University Lesprojekt base station and Lesprojekt agronomy device. Node works as a transmitter and data logger between luminol probes radio network and GSM GPRS network. Test probes are placed in a stable to simulate the real radio signal condition of propagation.
Quality data for year 1 of the AS07 demonstrator on the AFarCloud project is made by SenseLog solution. It is web-based sensor data management solution. This central data storage for all collected data over the year 1 period is managed by University of Slovenia. This SenseLog solution is capable to store, preprocess and publish this sensor data in various ways. From all the sensors, we are receiving data by REST API by system of web services, and in case of different communication interfaces, we are using system of connectors that is used for transferring data to correct form and to be able to connect to SenseLog interface. All data are stored in one database model in one central database for the demonstrator. Data are preprocessed to be able to query this data and to publish them in standard interface. Data from SenseLog are published by, again, REST API to different components that can use this data for further processing or visualization. In case of AS07, most of the data are published to a visualization component provided by Charles University called EVIS or AFVIS. It depends on these data are visualized in form of charts to be able to provide farmers and users the best form how to interpret this data. On the other hand, we can provide this data from SenseLog over REST API to AFarCloud cloud to be able to use it by other partners or by other components of the cloud.
All the data from the demonstrators are visualized within the EVIS visualization framework. This framework is highly customizable framework for visualization of any kind of the data. For the AFarCloud, for this demonstrator, the data are primarily visualized via the line charts. These line chart visualizations allows both the filtration of the data and also the aggregations of the data based on the different parameters. Again, everything can be configured. Also, it allows to zoom data to see different details.